Welcome students in the organic chemistry lecture series. In this video we are going to study about the optical isomerism. In previous video we have seen the basic concept which we have to understand for studying this optical isomerism, and that was what is plane polarized light, how it is obtained, okay, what is optical activity, so what is monochromatic light, what is specific rotation. So all that concept which we have seen in the last video that are important to understand this concept, that is optical isomerism. As I earlier explained, optical isomers are of two types. First one is enantiomers, and second one is diastereomers. Today in this video we are going to focus on this enantiomers. We have to study in detail about what is meant by this enantiomer. So we'll see what is enantiomers. Okay. Now before going to in detail with this enantiomer, as I said earlier that for a compound to show optical isomerism, for a compound to show optical isomerism, it must show the phenomenon known as optical activity. This thing I have explained already. So for a compound to show optical isomerism, it should be optically active. We can say compound should be optically active. And which compound is called as optically active? The compound which rotate the plane of plane polarized light, plane of plane polarized light to left or to right is called as optically active compound. So this is very important. Okay, so if the compound is optically active, then and only then it can show optical isomerism. Okay, in a previous video I have explained you that when we keep the sample, and if the plane of plane polarized light is rotated by that sample, then that compound is called as optically active. Okay, so it can rotate the plane to left or to right. If it rotate the plane to the left, then it is called as levorotatory. This I have explained already. And if it rotate the plane of polarized light to right, then it is called as dextrorotatory. Okay, so for a compound to show optical isomerism, it must be optically active. Okay, now we'll see what is meant by enantiomers. Which compounds are called as enantiomers? Okay, first of all we will see the definition of enantiomers. Enantiomers are the optical isomers which are now this word is very important, which are non superimposable. This word is very important. Non superimposable mirror images of each other. Mirror images of each other. Okay. So optical isomers which are non superimposable mirror images of each other are called as enantiomers. Now when we see the example, at that time you will clearly understand what is this enantiomers. So up to now you just remember that optical isomers which are non superimposable mirror images of each other are called as enantiomers. The synonym of enantiomer is enantiomorph. It can be also called as enantiomorphs, इसको हम enantiomorphs ही कहते हैं, या फिर इसको ऑप्टिकल एंटीपोड्स भी कहते हैं, ऑप्टिकल antipodes. Okay, so the compounds which are the optical isomers which are non-superimposable mirror images of each other are called as enantiomers or enantiomorphs or optical antipodes. Okay, enantiomers have same physical and chemical property. This is also very important. Same physical and chemical properties. Okay, so what is the difference between the pair of enantiomer then? It has same physical and chemical properties, but they rotate the plane of polarized light in opposite direction. Okay, so this is very important. What is the difference between pair of enantiomers? They rotate the plane of polarized light in opposite direction. Okay, now I will take one example so that you will easily understood what is the enantiomers. Say for example, this is the compound, simple compound lactic acid. I will draw the structure of lactic acid so that you will easily understood what is meant by. Okay, here is hydrogen, here is a methyl group. Now suppose this is the structure of lactic acid. Now if we place the mirror here, यहाँ पर अगर हमने मिरर प्लेस किया तो हमें इस साइड का स्ट्रक्चर कैसे दिखेगा? See here, this is OH, CH3, H, and here COH. Now see this, both these are lactic acid. This structure is of lactic acid, but you see here the structure. This structure is the mirror image of this. Both are mirror images of each other. But what kind of mirror images? They are non-superimposable. What is non-superimposable? If we lift this molecule and place this molecule on this molecule, then these are non-superimposable. Okay, like if we place our right hand on left hand, it is non-superimposable, but our hands are mirror images of each other. In the same way, these molecules are mirror images of each other, but they are non-superimposable mirror images, so they are called as enantiomer. Now this will be say L or minus lactic acid, and this will be D or plus lactic acid. अब ये D and plus क्या होता है इसके बारे में बताता हूँ. Small d and small l, these are the notation to represent the specific rotation. Small d means it is dextrorotatory, that means this compound rotate the plane polar light towards right, and L stands for Leo rotatory, that means this compound rotate the plane polarized light towards left. Similarly, instead of D we can use plus sign, and instead of L we can use minus sign. The meaning of plus sign is also dextrorotatory, and the meaning of minus sign is also Leo rotatory. So I think what is enantiomer ये आपको clear हो गया है. We'll see some more examples so that it will be very clear to you. Okay, we'll see one more example of enantiomers. Suppose see the Fisher projection formula here. Here is Cl, here is a C2H5 suppose, here is a hydrogen, and here is suppose a methyl group. Now if we place the mirror here, then we'll get this compound Cl, CH3, C2H5H. So these are the pair of enantiomers. These are the pair of enantiomers. Okay. So name of this enantiomer is plus, or we can say D. This is minus, or we can say L. So this is the example of enantiomers. Once again, I will summarize. Enantiomers have same physical and chemical properties. You remember, chemical properties. They have only difference in the rotation of plane of polarized light. They rotate the plane of polarized light to same extent but in opposite direction. Okay. So out of the pair of enantiomer, one is dextrorotatory. Say here this is dextrorotatory and one is levorotatory. Okay. Dextrorotatory is designated by small d or plus sign. Levorotatory is designated by small l or minus sign. Okay. They have identical physical properties like अब ये दो कंपाउंड अगर हमने कंपेयर किए तो इनके फिजिकल पॉइंट्स जो रहते हैं मेल्टिंग पॉइंट या फिर बॉइलिंग पॉइंट डेंसिटी ये सेम रहते हैं लेकिन उनका ऑप्टिकल रोटेशन जो है वो अलग रहता है. Okay. They also have similar chemical properties. However, if the chemical reagent is asymmetric, then they may have different properties, we can say. So this is all about the enantiomers. So I will once again repeat, enantiomers are the optical isomers. Optical isomers, they are non-superimposable. This word is very important. Non-superimposable mirror images of each other. Mirror images of each other. Okay. So I think uh, this point is very clear to you. So in this video we have seen what is enantiomers, one of the type of optical isomers in detail along with examples. In next video we will see about a diastereomer. So till now we'll stop here. Have a nice day. Thank you.